Limiting reagents. This is kind of a tricky lesson. Yeah, and I would enjoy not doing it on a Friday afternoon, but we don't have enough time to play around with the schedule anymore, so it just has to happen. So this, there's quite a few steps to this, so please pay attention and ask questions right away if you have any, okay? Yeah, but the steps are a little more complicated than as the notes make it. So, with limiting reagents, Brody, stand please. So with limiting reagents, what's going to be happening is you're going to be given two masses now. Okay, so you're going to have two known variables, and you're going to have to know, they're going to be both the reactants, right? In reactions, you have reactants, and they produce the products, right? So you're going to be given the masses of both reactants now. And what happens in a chemical reaction is one of them is going to get used up first, okay? And then the other one won't have anything left to work with, and the reaction stops. Okay, so it all depends on which reactant gets used up first in the reaction. And the first one to get used up is known as your limiting reagent. Okay? You know, you hear that like you're only as quick as your weakest link. Your limiting reagent is your weakest link. It's going to run out first. Once it runs out, the reaction's over. Does that make sense?
Why don't we just like...
Yeah. You need it for Chem 30. Okay? So, there's an example here. Okay? So, for this example here, let's say you have 2 moles of magnesium, and you have 5 moles of oxygen. So what we want to know is which one's going to be the limiting reagent. Magnesium? You think it's going to be magnesium?
Would it be magnesium because it's hot?
Not necessarily.
Oh.
Yeah, like sometimes it just works out the smaller number will be the one. You have less of it.
Wait, so if there's like 2 in the front,
Well, you know you're going to need 2 moles for every 1 mole of oxygen, right?
So oxygen is small.
So like let's say you had 2 moles of magnesium. How many moles of oxygen do you need for that? Well, you set up your ratio of want over no. Yeah. Right? And you only need 1 mole. Okay. Do you have 1 mole of oxygen there? You have 5, so you have lots. If we went the other way, I have 5 moles of oxygen, and I want to know how many moles of magnesium I need for that. I would set up my ratio of what I want over what I know.
Wait, yeah, because then you probably need
So you
5 times 2,
5 and 2.
10 moles.
and you don't have that?
I don't have that, do I? I only have,
So it'll only ever work on.
right. Only one of these will be your limiting reagent. So do I have enough magnesium here?
no.
No, so that's your limiting reagent. Okay? Does that make sense in a way? It shouldn't make a ton of sense. You should, though, see you don't have enough. Right? I need 10. I only have 2. Does that work? No. Here, I need 1. I have 5 moles. Will that work? Yes. Thank you, Connor. So, the key to this is just keeping things straight. All right? So, the steps for these are always the same. Balance the equations. Okay? That doesn't change. Calculate your moles for both. Okay? Label 1, reagent 2, and then you compare the moles. Okay? Just like we did up before. Okay? I'll go through this, and I'll try to make the steps as simple as possible. Okay? Show you guys how to do this, or how I do it. And make sure if you have questions to ask right away. Don't just sit there lost. Okay?
Is this the hardest?
Yeah, this is the hardest thing you'll do.
You mean lesson?
Yeah, this is the hardest lesson. Okay?
Another lesson after this?
There's one more after this.
Really?
Yeah, I mean, that's it.
Can't wait, but we also have to do that third thing as, so I want to try.
If we don't get to bond energy, guess what?
It's not important.
It doesn't go on the test.
Not important.
It's important, but not as important.
Then can you tell Miss LaFontaine that we did learn that?
I'll deny that to the end of it. No, I taught him everything. So, sorry. It'll be fine. And I don't think bond energy is needed in the chemistry. So, you
I'm
shouldn't
good
be
at chemistry, as long as I pay attention.
good. That's key.
Supposed to have a woman.
No,
Now,
I don't pay attention to anything.
thanks, sir.
Other than that.
Now, so if the mole-to-mole ratio gives you a smaller number than the calculated value, then the reagent is in, say, excess. Okay, so when I did the reaction up here, see how I have 5 moles, but I calculated I only needed 1.
That's an excess.
So I have excess, I have extra. I don't know how to spell it.
Yep, you did fine. Perfect.
Thank you. What's your questions here?
So I was just gonna ask how you got 5 of it.
Yeah, it's given in the question. Then if your number is larger, so like I did the comparison, and 10 is bigger than 1. So that means this has to be, or bigger, yeah, bigger than the 1. So this has to be,
Well, I mean, 10's bigger than 2.
oh, 2, sorry, I don't know where I got the 1 from. 10's bigger than 2, so that means this is my limiting reagent. I don't have enough. Okay, that's what those 2 statements at the bottom are saying.
Yeah, buddy.
Okay, now, let's try one of these.
I still don't understand what you said, but okay.
Just follow along, Sierra, you can do that.
Who really Mr. Grace that works with us? Yeah, that's gonna confuse me.
What word?
Like, you just start. No, he said that was a good one.
Alright,
Yeah,
okay. Sorry, I went through and did these beforehand, just to make sure I could still do it.
Oh, you with yourself.
Yeah, because I haven't taught this for a few years, so I'm like, yeah. Okay, now, Connor. Thank you. All right, so 2-gram sample of ammonia is mixed with 4 grams of oxygen. What is the limiting reagent? How many moles of the excess reactant remain after the reaction is stopped?
Balance equation. Balance equation.
Very good. So let's see here. My nitrogens are good.
Boom, I balanced it.
Oxygen, let's do that next. Oh no, let's do the nitrogens or the hydrogens first. Put 2 there. 2 there. So I have 3. Oh wait, I need a 2 gram.
I never proofed it. I was proofing. Darn.
I didn't do a fraction. No.
I would do a fraction. I'd do 5/2. If you don't want to do fractions, you can write. You just double everything. 4, 5, 4, 6. It's up to you.
We can do that?
Yeah, absolutely.
That's awesome. I love that.
So it's up to you.
Mouthful.
The fractions get people a little more confused with the ratio stuff, but it's not the end of the world.
How do you get 5 over? Yeah, like how do you know it's gonna be?
Okay.
5 and you have 2.
So yes, I need 5, right? If I look here, I got 2 and 3, which is 5 in total.
Right.
I need 5 over here, but I already have 2. So I got to multiply that by 5/2.
You get 2.5.
Yeah, so 2.5 times 2 is,
But he
5.
doesn't like that.
Yeah, no, you can't, that's not recommended. It looks weird.
You know that's what's weird? Brody, but we still love him for what he is.
Love the strong word. Okay, so 1 and 2. So let's calculate the moles of each.
How many times I tried to do this last
So for ammonia, it's going to be 2 over the molar mass.
2 grams.
Oh, you're gonna show me formula?
So I'm not going to go through the steps of calculating the molar mass anymore, because I'm assuming you guys can handle that.
Mass of.
Well, I did the questions beforehand this time. 2 grams.
So are you only supposed to find the reactants?
Yes,
Yes.
yes.
So why did you put a 1 on the top?
Because isn't that what you guys just do?
Just to like sort.
Oh, we're not doing 1.
Yeah, we're not doing water, no, we're finding moles. 2, so it's 2 divided by 17.04. You should get 0.1174 moles.
I did that.
Jaden, your math, please, bud. Thanks, sir.
Oh, okay. Wait, so you know the molar mass is 17.
The cell of nitrogen, of
Are
ammonia,
you sure
sorry.
you did your decimals right, buddy?
Oh,
17.04, it should be 17.15, isn't it? Or am I stuck at that?
Nitrogen is 14.00 or 1401.
Mr. Weber just counts H as 1. Not 1.
Well, no, I did 100. I did it like this.
1.00.
I go to 2 decimal places.
Is that? Oh, that makes
So our
And I get 17.0.
Okay, wait, yeah, but and since all of us go like different rounding things, that's all.
As long as you're close, I can figure it out. Okay?
Okay, I got that.
Okay. So that's the moles of ammonia. Now we need the moles of oxygen. So that's going to be 4 grams divided by 1. Oxygen is 16. So that's 32. 28, so like 0.65. 125, sorry. So that's how many moles we actually have of both of these.
Then that's oxygen.
Yeah, that's moles of oxygen.
Okay, so like when you're writing moles of like, oh yeah, so you go into like the thing at first.
No, you don't use the coefficients yet. All right, now, let's check this out. Which one do you guys want to use? Do you guys want to use ammonia or oxygen?
Does it matter?
No, it doesn't matter.
I like that number.
No, ammonia.
Oxygen.
Yeah, oxygen. Oxygen.
They want oxygen.
I was trying to.
I just figured you were just trying to be different.
The 0.125 does look better. I think, we want 11 cents before.
Okay, so, oh, whatever, sorry, you guys said oxygen. Connor got in my head.
Yeah.
Darn it. Okay, so, want over no, we want ammonia. We know. Oh no, what do I do with my cool kid calculator? Oh. So make sure you guys are trying this, just make sure you can do it. Yes.
I forgot to type the question thing. I didn't know what that either.
0.1. 0.1.
0.1.
So.
I realized it right after I said, I was like, wait a second. I still can't do that.
Casey, what do you think?
0.05. Yeah, 0.025. No, like,
If you get 0.1,
right.
Oh.
Two, see?
Yeah, I didn't do it that way. I did it 2.2.
Oh, no, yeah, you gotta double it. This is gonna be a 4 here. If you didn't do a fraction, your ratio is 4/5. 4/5? You did do a fraction. You did a fraction.
Oh, I got 0.1.
Thanks.
So you put in a fraction. She got it in 0.1.
Well, I don't know, but I just like highlight it. But mine, I after I got highlights, I went back.
What up, man?
Mine are all like.
Hey, what up, my neighbor?
You guys should high five. And really, it isn't.
Whoever's making the recording, just leave the recording for 20 minutes.
Oh, that's what double speed is for. I don't care. Okay. This video is going to be like half an hour long. Now, let's bring it back in. Huddle around, children. Okay, I got 0.1 mole. We all got that, right?
Right.
Now, I have 0.1 moles here. How many moles of ammonia did I need? Or do I have? Sorry.
0.11.
Can you write that what that is? Like, is
Okay.
that moles of ammonia?
This is moles of NH3 needed.
Oh, that's what
Okay, I took my moles of oxygen and I times it by the ratio.
Okay, wait, but you have way more than that.
So I have enough, don't I?
Way more.
So also then that means you're limited reagents.
What's that?
That means you're limited reagents.
It's oxygen.
No, it means, yeah, oxygen's limited reagent. I have enough.
What? Wait, this is a different question than last time. Okay.
Okay, so I have enough. If you did it the other way,
Wait, didn't we do oxygen first though?
we did. Okay, so we took oxygen and I calculated how much ammonia I would need. I need 0.1 moles of it. I have more than enough. So that means it's in excess.
So it has to be good.
Right. If I would have done this the other way, if I would have went and found the moles of oxygen that I needed, I'm going to get a number that's going to be bigger than this. Okay?
Wait, but then, if it's bigger than that, then do you not have access to it?
No, if it's bigger than this, then you don't have enough. You're going to run out.
That would be your LR.
Yeah, then it's your LR.
But, so is that just like an easy way of figuring out your LR?
Yes.
Oh, no.
Okay, so I have more than enough. So if I have enough of that, so you do a little therefore, oxygen is,
Wait, don't you need
That's what I said.
Yes, he said that's right.
He did say it's right.
yeah, I'm agreeing with you. I have enough ammonia. I have more than enough, right?
Also, you agreed with me when I said it was limited reagents.
Yeah, so oxygen is the limiter. You're always so confrontational. Yes.
But so it's 0.1, and what you needed was 0.11.
No, what I have. This is what I have.
Oh,
Right?
okay.
2 grams is what I have. Okay. Now. This is what I need. Okay.
Okay, I'm just confused because like you got your moles of your stuff.
Yes.
Yeah.
Here.
Okay, and then and then you have your numbers.
Yeah.
So that's your NH3 moles, that's your oxygen. So I don't know what the heck that turns
Oh,
into.
yeah.
Okay. Guys, listen up for a second. So what I did. This is what I have of each one, right? Brody, Sam, please. This is what I have of each one, right? So I took what I have. If I have this much oxygen, I calculate how many moles of ammonia I need to react with that by using my stoic ratio, want over know. And when I do that, it tells me I need 0.1 moles. Okay? So then I look, this is what I need for the reaction to happen. So I go back and I compare that to what I actually have. And I have more than enough, don't I? So that means the rest of it is in excess. So I have extra of this. So that means I have just enough. So that means oxygen is my limiting reagent.
And do you do it the other way?
No, you don't have to do it the other way. If I would have done this the other way, don't take this down. So let's say I took my moles of ammonia and worked my ratio the other way to find out how much oxygen I need. You don't have to take this down.
5 over 2 over 2.
5 over 2 over 2. That number is 0.147. That number there is bigger than this, isn't it? I don't have enough oxygen. So oxygen's going to run out first. That's my limiting reagent.
You understand?
It's going to take time.
Not really. I mean, really good.
All right.
I understand.
Does it, Danita?
Yeah. This is way easier than this idea. No,
This is stoichiometry.
well, whatever that gas stuff we were doing.
This is literally want over know
I
stuff.
don't think I can do the hand into the gas stuff. Yeah, I haven't even started. I can't
You
do
can't do
that.
stoichiometry yet? No, that's
But
not.
this is super easy. This is way more complicated than stuff we did yesterday. Stuff we did yesterday, I couldn't do any of
You
it.
guys are bad. Okay.
Stuff we did
Okay.
yesterday was fun.
Everyone, sit here. Let's.
They were like,
I wrote this.
Now,
it's like.
the last part of the question says, how many moles of the excess reagent remain after the reaction is stopped?
So it's all oxygen elimination?
Yes. So oxygen is limited reagent. Ammonia is in excess. Okay. So what we do, we want to find out how much ammonia is going to be left over. You take what you have and subtract what you're going to use, which seems fairly straightforward, right? So you take your limiting reagent, what you have.
So would you do like, yeah, that, then subtract the point?
Yeah, this is what you have. This is what you use. And that's going to give you what?
And what's that the answer to?
That just tells you how much you have left over.
Oh, so the other answer on that.
Yeah. Well, if I ask for it, it's like, sure.
Okay.
Okay. Okay. This honestly isn't the worst go at limiting reagent stuff I've had in class.
Oh, honestly,
No, this is great.
this should be your best.
It's not the best. It's not the worst.
Who's the best?
I had a class in Elder. They were smart.
Yeah, but they're not.
Yeah, if we could go Brody, would that have a better average?
It's definitely Deb. No.
No, he's pretty smart. Not
Yeah, he is.
but-
You're a big brain. My average is one more.
What is your average? What's your average?
I don't know what my average is, but I know it's one more than Connor.
You don't know it, but Connor was average.
I know I'm beating you.
Connor was average.
I don't know, like 87 maybe?
Yeah, it's not so big.
Did this happen with Ethan? You had to
Yeah.
go to work and-
Yeah, that was on the SDS outside.
No, but, oh,
I
wait.
was in every test.
You guys are like just savages to me.
No, it's because you think
It's
you
fine.
Yeah, we don't like Ethan.
No,
No, I love Ethan. He's so vulnerable. Yeah.
he's like you. You can just chirp him at like everything.
He'll
he
just
does.
take it.
But I'm an adult.
Yeah, exactly.
He's just a little guy.
He's not an adult now. So whenever Ethan knows, he cracks.
That does sound like him. That's a pretty good Ethan
He's working
impression.
home today, I'm gonna tell him.
That's awesome.
Tell him I say hey.
How am I saying hey?
Yeah. That's funny.
Hey.
It's a grown man be like, say I'm gonna say hey.
Oh my gosh.
That's the joke. Okay? Alright. Next question. Or iron chloride reacts with hydrosulfuric acid.
Oh, boy.
All right. What is limiting reagent? Connor, your math.
Okay.
My bad. He knows exactly what he's doing. Just quit his conversation.
That's good. All right. So let's write out the equation. What type of reaction is this going to be?
Single replacement. Double replacement.
Double replacement.
Sorry, I never saw the S there.
I forgot that we have to actually write out a reaction.
S? No. H.
So I'm going to get hydrochloric acid and okay. I'm hoping you guys are okay with writing out the equations like this.
Oh, there's two irons.
Okay,
Different options.
very good. So how did I know to use iron 3?
Because of the neutral or the
The charge on
charge.
the CO. There's
Very
already
good.
balance there.
Right. Cl has a charge of 1, or negative 1.
Yeah.
So this has to have a charge of plus 3.
Is all this garbage gonna be double replacement?
Most of the time, yes. So let's balance it now. I need a 2 there.
Use 6, okay.
3.
Oh, bullet down.
Not Christopher.
Okay. Now, technically for this part, oh yeah, I did need it. Okay. So I'm going to call this one 1, this one 2. So let's calculate the moles we have of each one. Okay.
Hey, do you think Justin Bieber's Christmas album is underrated?
Never heard it.
Yes, you have.
No.
You've heard Miss Kid. You've heard Miss Kid. Reagent's singing it right now.
I don't listen. Okay, gentlemen.
Okay, wait.
Don't blame it on your sister.
Which one are we doing?
Junior math, but telling you right.
Since you're doing number 1, so you found the molar mass of F in CL.
Yeah. Cl is, so 35.45 times 3 plus iron. Where is iron? 55.
162, oh my god.
Okay?
Why is it 162?
Well, that's 3 chlorines and 1 iron added together. We don't have time to go over this anymore, so I'm just molar mass.
James, you can't talk to you like
Nothing goes out. It's just like stars.
Be like,
Nothing. To get more mass. I get that.
Hey, so I have
why can't we find iron solid?
okay, so those are my moles of iron chloride. Iron 3 chloride, I guess you could say. Okay. Does anyone have any questions about these numbers?
No.
Okay.
It's stuff easy.
As a
Connor, your
This
math.
step.
Now, for the hydrosulfic acid,
H.
so sulfur's 32.06 plus 1.01, 2 of those. So it's going to be 52. That's a 34, by the way, not 39. Sorry.
Is the other one a 9?
Yeah, that's a 9. 34.09. Let me make sure I got that right.
that's 3 sulfurs, correct?
1 sulfur.
1 sulfur, but the 3's in front.
You don't use the numbers up front, just the little subscripts. 2 hydrogens and 1
Here,
sulfur.
I wanna win, like, I'm not like.
I thought this is the same question me and Macy had yesterday.
No, it definitely would not have.
No, this is. Can you imagine taking?
1.525. Go! Okay. Now, those are the moles I actually have of everything. Let's go.
Let us get this right. That's fun. Now let's do,
Should we take?
which number is better?
Let's do
Number 1 again.
No, it's number 2 plus.
Yeah, we did number 1 last time.
Okay, fine. I thought we did 2 last time. We did do 2 last time.
Oh, we did do 2. Let's do number 1.
That's what I say.
Okay, I'm with you, Brody. Can't do that.
Alright, take it back.
Thank you. Thank you.
He goes,
You guys are idiots. All right. So, I'm taking my moles of iron chloride. So I set up my ratio. I want H2 or H2S. I know the iron. This is going to be close. But I think I know what's
Why don't you just unplug it? Like, and just say a kid did it. How would I unplug it and then you can say I did it?
I unplugged it last year, and I kind of got told I shouldn't be doing that.
Well, because then we get locked outside.
Yeah, because like if it's especially in the wintertime, if a kid gets locked out when it was -30, it doesn't look good if I said I unplugged it.
Hey, it's nice outside. Then why did they lock it? Literally not even opening the door.
Someone will get it. Don't worry about it.
Don't worry.
we don't like
None of you guys got up to open the door, so why are you like coming at me for not doing it?
Oh, I didn't tell you.
We're not allowed to do this last night.
That's true. No one's going anywhere.
Is that not FPC?
Oh, I said that.
Say,
I won the argument.
okay. Fine. Say it again,
Is
here.
that not FPC?
This here is our moles of FBC,
Okay, yeah.
and I calculated this is how many moles of H2S I need.
Yeah, but then you don't have enough of that. So is that not your limiting one?
Well, let's see. This is how many moles of H2 or hydrosulfuric acid. Yeah.
Is it? But then you multiply by your thing, so does that not make? Oh, I see.
Yeah.
Good job.
So
It's our limit.
this is how many moles of it I need. How many moles do I actually have?
1.5.
So guess I got more than enough.
Oh.
So this one's going to be excess.
Oh, I looked at it. I'm gonna mess that up. I always look at it backwards.
I know, same.
This will be my limiting reagent.
I'm so confident.
I have more than enough. Okay.
Just remember when you're doing the molar mass, that's half.
Look at that.
Half. I swear my face it just runs down.
I know. I'm not giving you crap. I'm just reminding you. It's like I'm telling Jade.
Then I think perfect.
It's literally you and Jaden.
Oh, I've been good.
And Brody. Brody's bad too. Brody, your mask is supposed to know.
You know what I don't like?
Are you still recording? Because I have something to say.
You know what I don't
Yeah, I
like?
am recording, so
You know what
please
I don't like?
don't say
Yeah,
it. And Ainsley, your mask. Must be
Ainsley's,
your
yeah,
mask too.
I was just gonna say, Ainsley's worse than me and Brody in English sometimes for law, and like she does not get in trouble.
Because people like me.
No, that's not true. People don't like it. What probably happens is Ainsley's not nearly as loud as the other two.
That is
Yeah.
so.
So you guys just put targets on your chest right
If
there.
you want to say something, I'm really interested in what that is.
Yeah. What is?
Pause for recording.
Okay, we're done. Okay, so now so this is our limiting reagent. Okay? We understand that, right? There.
Yeah, because you don't have enough.
Oh, that's just looking up.
Right? Yeah.
So what does the mass of HCl produce?
So now we have to do stoichiometry.
Can you go over this?
Yeah, you stoic.
No.
With the limiting reagent. Okay? So you use the moles of the limiting reagent.
Okay, that's cool. I like that. So you use H2S.
You always use the limiting reagent, okay?
That's
So
So you use FEC.
I added the.
if you don't, because the limiting reagent's going to be used up first, right?
You use your moles of that.
Yeah, the moles of the excess don't get used up, so it won't give you an accurate reading.
Oh,
Go
that's
to your,
I.
and you use your mass.
So my moles of my limiting reagent again are
0.5549. How the heck, wait, how do you spell that?
More mass over.
And you want.
stoichiometry. This is just shorthand.
Oh, where's the, oh, it's
One,
stoic.
one.
Oh,
Yeah.
no. Time, one. You want.
So go back to the original balance equation.
Two.
This is what I want. HCl. This is what I know. So 6/2.
3/1.
Or 3/1. So those of you struggling with stoichiometry, does that part make sense?
Wait, so we aren't turning it into mass, yeah, we're turning it
Well, I need to get the moles of it first.
Is that not?
Well, it already is in moles, so once we get the moles of HCl, we turn that into mass.
Oh, why didn't your stoichiometry ratio instead of just turning it into mass?
Oh.
Why would it? No, no. You need the moles of HCl first.
We're looking for HCl, not
I'm not converting. Yeah.
Sure.
You're lost here, so bad.
So like this, you know the step before you do that.
Did you do
We're
this
saying we
already?
technically already did that.
What's that?
Did you do this already?
Yeah.
So can I check my answer with you?
Like final answer?
Yeah.
60.7.
60.7.
Yeah, wait, so then you take that and then whatever you get for that, you turn that into.
Yes.
Oh, I got 6.7.
Nice, I actually got.
So Sierra, follow me for a second. This is my moles here. Sierra, this is my moles of iron chloride, right? I'm going to times that by my ratio.
What? So why are you doing H?
Of what I want HCl, right?
Yeah.
So 6, look up here. Want over no.
That's not 6 over that number.
Yeah.
What did it equal to? 36.46.
36.4?
Wait, what was the number? I don't remember.
60.7 is the final big answer.
Yeah. So those are my moles of HCl. Now I times that by molar mass here. I get a molar mass of like what? 36.46.
Is that in grams? Is the final answer in grams?
Yeah. Oh.
Mass though.
Volume's always in meters.
Distance is always in meters.
I don't know why, but I like my teeth better.
60.7 grams.
They might have because they look like because they look so much perfect.
Okay, so I'm not the only one.
How are we feeling? Everyone with me?
Yeah.
Kiss me underneath the mist.
I'm like with you, but like,
There's a lot of steps here. And we took a minute to stop
I
and
just thought you're supposed to go like at first to 0.55 and turn that rate into mass.
no, because that's your moles of iron chloride. So I gotta find.
I have a question.
Yeah.
So then if we were just looking for HCl, why didn't we use, oh, because we have to use our L1.
Yeah.
That's so dumb.
What massive excess reactant remains there?
Ooh, that's nice. Okay, so massive leftover reactant.
So then we just take your leftover reactant and times it by the total mass.
Yes, very good. Connor George for the win.
What did he say?
Okay, so we want to find the mass of the excess reactant remaining. So you find the moles left over and just times it by the molar mass. So I had 1.525 moles of H2S. I know I used
Oh, what do you use?
this much of it.
So then you have your excess.
Yeah. So I find out how much is left over.
Wait, where did you get your 1.66? Oh, you all was 1 point. Okay.
Sorry, is everyone okay with this part?
Yeah.
Okay. 0.6926 moles left over.
Are we gonna do practice stuff on Monday?
Yes. You guys want to do some practice before the bell
No.
while it's fresh?
I mean, I'm good, but.
Well, what time?
It's like 5 after 3.
Well, yeah, we'll attempt stuff, so we probably won't get much time.
So I know my molar mass of H2S is 34.09. So
Wait, okay, but don't you just take your first, like the actual moral mass of it, and then just subtract by the other one?
yeah, that's what I did. Those are my moles, not molar mass here. I times it by the molar mass
Why?
because I need it in grams.
And your answer was, Mr. Weber?
23.6.
This is the moral mass of like what?
Wait, why do you?
This is molar. This here is the molar mass of H2S.
Why do you?
1.6 grams?
Why did you subtract 0.8324?
Because this is what I
That's
okay.
the access.
This is what I had. This is what I had. This is what I used.
I don't know how to say
You just did it.
access.
Yeah, instead of axis. Sam, what's up?
Is 23.6 the answer?
Yes.
So wait, can you just say one more time to give that out?
Okay. I found out this is how many moles of H2S that I have left over. This is the excess, right?
Why
So-
don't you get 20?
Just listen. So I take the moles that I have left over and I times it by the molar mass. And what that does is you go moles times molar mass. What does that give you? The mass. So that'll tell me that I have 23.06 or 6?
No, just 0.6.
0.6 grams of H2S.
Are they 2S left over?
Yeah, left over. All right, those are the examples. Now, with the exception of the pause that we took to talk, to do this question took probably 15 minutes. It's gonna because there was lots of questions and whatnot. These are longer questions. You're not going to get a ton of them on a final exam. There is going to be one like this on the exam.
Only one or like a couple?
Well, one this long. There might be a couple limiting reagent questions where you got to calculate which one's the limiting reagent.
It's so long.
I feel like the orange is like gonna be stuck in my brain way more than like.
I'm gonna bomb the ray diagram. Like the light ray.
I don't remember what.